Unit 11, Lesson 1, Venn Diagrams. The learning targets for this lesson are to identify probability notation within a problem, to calculate probability, and to use Venn diagrams to determine probability. Probability is typically a topic that you maybe learned in a previous math course, and it's the likelihood of an event occurring. So typically we think of this as the number of favorable outcomes, or what we're wanting to happen, over the number of total outcomes. Probability can be written sometimes it's written as a fraction. We're also going to see it written as a decimal and sometimes as a percent. So for example, in example 1, it says in a production of 1,200 iPhones, 8 were found to be defective. What is the probability that you choose a defective iPhone from the batch, right? And if you notice, the question says write the probability you can either write it as a fraction, a decimal, or as a percent. So when we write this, our total number of favorable outcomes, or what we're trying to focus on here, is that there's 8 that are defective. So the number of favorable would be 8. The total possible that are in there, or the number that we call in our sample, like our sample size, sometimes we call that n, is 1,200. And so when we write this, we can actually divide this out. So 8 divided by 1,200, or 1,200. If I was to write it like with maybe 3 decimal places, I would get 0.07. Or if I turned it into a percentage, that would just be simply multiplying it by 100. So that would be 0.7%. So when we talk about probability, we're always looking at the number of favorable outcomes over the total number of outcomes. Some other notation that we're going to end up seeing in this section is talking about intersection and union. So an intersection is defined as a set that contains elements from both A and B. And we're going to see an example of this in a moment. Typically when we see intersection, it's written as almost like an upside down U, the intersection of A and B. And these are usually values or elements that belong in both, have characteristics of both A and B. The union is a little bit different. The union is it's a similar looking notation, but instead of being, upside, looking like almost like an N, it looks like a U. And these are elements that could be in either A, B, or both fall in A and B. We're going to see later that when we calculate probability for a union, we want to make sure that we're not counting any values more than once. So that's why this one looks a little trickier. It's really just making sure that if we do have any overlap, we're not counting that overlap more than once. So for example, example 2, just simply creating a Venn diagram. This is similar to how you would use a Venn diagram for like an English or a social studies class. And we're given these two sets of numbers. So set A and set B. For this Venn diagram, we might want to label it out. So maybe the one on the left, I would call that maybe A. And then the one on the right, maybe I'll call that one B. Okay. And really all we're going to do now is take these values that are listed in the set and just place them within this Venn diagram. So for the easiest way to do this, I usually tell students is just start with one value. So I'm going to start with maybe the number 1 here. I'm going to look to see if 1 falls into the other set of numbers. It doesn't, and so 1 the number 1 would just simply be in set A. And then maybe I'd cross it out to know I can move on. The next one we have here is the number 3. The number 3, you can see it falls in the second set. So 3, I would actually put in that where the circles overlap, and maybe I'd cross it out in both. Just so we can make sure we don't count that 3 again later. Putting it in that intersection counts it for both sets already, so we don't want to put that in again and then accidentally count it twice. And then you can simply just kind of do the same thing here. So, for example, 5 doesn't, would only fall in A. 7 would only fall in A. 9 actually falls in both of them. So I put 9 in the intersection. 11 would only fall in A. 13 would only fall in A. And then 15, you can see actually falls in both of them. Okay. For the remaining values, you can see 0, 6, and 12 only fall in set B. So notice I'm putting it in the part of the circle where it's not in the intersection. And so if you were asked to write what the intersection of A and B is, the intersection again is that it's in both sets, right? So it's in both A and B. So the intersection for A and B, that's what that little u means, would basically be these 3 values that fall within those circles. So that would be 3, 9, and 15. For the union, it's a little different. Again, it can fall in A, B, or both. So the key here is we're really picking anything that falls within these 2 circles, but we're not going to count anything more than once. So, for example, I see I have 1, 5, 7, 11, and 13. So maybe I'd list those. I also have 3, 9, and 15. That's that intersection. And then 0, 6, and 12. So the intersection is just writing the overlap, where the union is identifying all the values that fall in either of the circles. In example 3, we're going to use the Venn diagram from the previous U-try to calculate probability. One of the first things we maybe want to do before we start calculating, probability of A and B and so forth, is know what quantity is being represented in this data. So what is our sample size? So a lot of times we refer to that as N. That's our sample size. And so when we're calculating these probabilities, we need to know what our total possible number of outcomes would be. So the easiest way to do that is just simply count it. So we have 1, 2, 3, 4, 5, 6, 7, 8. So N for this would be 8. So anytime we're calculating probability, our total possible outcomes that could fall within this would be 8. So the first question is asking what is the probability of event A happening? And event A happens to be, in this case, factors of 12. So when we look at for event A, I'm actually gonna go ahead and highlight or trace this circle. So the number of values that fall within that circle I just highlighted would be considered our favorable outcomes. So in here I have 1, 2, 3, 4, 5, 6. So my number of favorable outcomes would be 6. The number of possible outcomes would be our sample size, which is 8. So if I was to go ahead and divide that out, that simplified it would be 3/4, or in this case it would be 0.75. For the probability of B, we would do it in a real similar way. So event B would be factors of 16. So I'm going to go ahead and trace this. And I'm going to count the values that fall anywhere within this green circle I just traced. So I have 1, 2, 3, 4, 5. So I have 5 favorable outcomes. Again, 8 possible outcomes. And so if I was to divide that out, my probability, and I might do 3 decimal places, is 0.625. For intersection and union, again, same thing. We're using the Venn diagrams here. We're still taking it out of our total possible, which would be 8. So all of these are going to have it be out of a sample size of 8. So the intersection, if you remember from the previous slide, we were focusing on, I'm going to erase this out here, we were focusing on values that fall within both of these circles, right? So the intersection, that's what this again means right here. The intersection means just that. Where do these intersect, or what values they have in common? So we actually have 3 values out of 8 possible. So the probability of the intersection would be 0.375. The probability of the union, again, that's just the number of values that occur within here. So we have here 1, 2, 3, 4, 5, 6, 7, 8. And obviously, you maybe didn't even need to count that. All of the values fall within those 2 circles. We're going to see on the next video where we would maybe sometimes have values that are hanging outside of those circles. But this one is just simply there's 8 favorable, 8 possible. So it'd be 1 or 100%. And the last one, you may have seen this notation in one of the earlier definitions we saw. That's the probability of not A. That's what that line above it means. So that notation means what's the probability that something doesn't fall within A. So what that means is if I was to take circle A, let's say circle, I'm going to highlight it here. So let's say this is, I have my circle A. I'm not going to want to include anything from circle A, right? So I would maybe go ahead and cross this out. So the only things that don't fall within circle A are 8 and 16. So those would be considered my favorable outcomes. That would be 2 favorable over 8 possible, or 0.25, right? So that line above, or that bar, means with probability of not falling within A.
If you have any questions, please make sure you ask them during T-ball time, during class, or you can come to the center. And remember, you do need to complete the You Try problems to receive full points for the notes.